Oh, g'day, Hayley. You're home early.
Yeah, I got a ride home with Joe. He's so cute.
What, in that old banger with all the panels rusted through? That's a death trap.
Nah, he borrowed his dad's new SUV. Talk about luxury. The seats are so soft. Oh, and it's got this really neat gizmo for telling you where you are and how to get where you're going. He showed me on the way home. It told him which way to turn every time he got near a corner. Pac-Man or something.
Oh, Navman?
Yeah, that's it. Do you know about it?
Yeah, they came and gave a seminar at Massey about it a couple of months back.
How does it work? Oh no, you've got that look on your face again. You know how it works, don't you? And what's worse, you're going to tell me.
Yep, sure am. You can't get out of it now.
I'm sorry I asked.
No, it's really interesting.
Sure, Dad.
It is. Look, just listen for a minute. You know it uses information from satellites to calculate where the vehicle is?
Dad, I'm not an idiot. Everyone knows about that. It triangulates the position from radio signals from the satellites in orbit.
Oh, get you. Triangulates.
Yeah, well, Joey was going on about it all the way home. He can be so boring.
Thought you said he was cute.
Oh yeah, he is, but he can be really boring as well.
Well, I bet he doesn't know about the rest of the system. See, the satellite part is just the global positioning system. That's been around for years. It's the rest of the system that's really good. See, just about everything we teach in computer science is wrapped up in that one little box.
I know I'm going to regret this. Go on, tell me more.
Well, we teach a whole lot of different topics in our degree, and usually a commercial product will involve only one or two of them. This one used everything. Of course, there's almost always some software in a computer science project, but programming's only a part of what we do.
True story. What else is there?
Well, computing systems do all have to be programmed, but like I say, there's a lot more to them than just writing out a whole lot of instructions for the computer to follow. I mean, well, the Navman system really is the perfect example. They needed special-purpose hardware, so they designed new chips. You know, integrated circuits, like the little black plastic rectangles in the printed circuit boards inside the PC.
Yeah, I know.
Yeah, from the outside, they look really dull and unexciting, but the internal design is fascinating.
You're joking me, Dad.
No, the black plastic's just camouflage to stop people swooning with delight. ICs are the most complex systems ever designed by humans, and if you're interested in designing things, they're one of the absolute ultimate challenges. And a few years ago, you couldn't even dream about making things like that in New Zealand, because the cost of setting up an IC factory was too great. But nowadays, you can go and buy things called FPGAs, field programmable gate arrays. They're pre-built chips that can be configured, modified electrically. Yeah, modified using electrical signals that you download from a PC. So you can turn one of those little bits of black plastic with legs into a special-purpose computer that does something really snazzy, like the navigation module. And that's just what the computer scientists who work for Navman did. They configured some FPGAs to do what they wanted, tested those to get rid of the bugs, and when they were working reliably, sent the design off to a chip fabrication factory in the States to get the real chips made.
And that's computer science, that computer design stuff.
Well, sure it is. Well, it's only a part of it, really. But I'm interested in it because one of my PhD students invented a new way of designing chips, and we had a dozen made to test his ideas. They all worked, too. And I've got another PhD student now who's working on doing something similar, designing a computer using a specialized set of diagrams. But the Navman system involves so much more computer science than that. I mean, there's the speech synthesis system for reading out the prompts to the driver. There's computer graphics for the display. Not as exciting as some of the graphics in computer games, but the stuff we teach works just as well for computer games as it does for things like the Navman display. And these guys even developed a whole new special-purpose programming language and an operating system for organizing the way the computer and the module runs. Used to be that only major computer manufacturers would ever develop something like that, but nowadays, with cheap FPGAs that can be made into special-purpose computers, it's possible for a little New Zealand company to produce what's essentially a complete computer system from the ground up. Now, what else do we teach that went into their system? Oh, data communications. You know, the stuff that supports the internet and cell phones. Well, that's in their design too. The navigation products can download new maps, and when roading conditions change, the road users can upload information into the database about places to avoid because there are roadworks or an accident, or a cop with a speed camera, which might appeal to Joey if what I've seen of his driving is anything to go by. Actually, I think the uploading part isn't fully developed yet. When I last heard, they were developing a special-purpose protocol to handle uploading road condition information from the in-car module to a base station.
A what? A polybol?
No, a protocol. A protocol is a standard set of messages that allow computer systems to perform some particular task. And of course, it's also got a geographic information system, a database of the road network in New Zealand that includes information about all the road names, speed limits, and a whole lot of other stuff that can help the driver navigate round the city. See, as Joey was driving home, The navigation system in his SUV was pulling together information about its location from the GPS system, and information about the road network from the database, and, of course, the information that the driver had given about the destination. And that happened each time it generated a spoken prompt about what to do at the next intersection.
Wish it was Joey's SUV. He could take me to the ball in it.
Wouldn't you have to get asked first?
Not me. If I tell him he's taking me, he'll do as he's told or live to regret it. It was a bit of a project, but I got him under control.
Oh, now, speaking of project control...
Walked into that one, didn't I?
Yeah. In order to get their system up and running, the Navman engineers had to coordinate a whole lot of different developments. They had to use the techniques that we call software engineering to keep it all from getting out of control.
Software engineering? Isn't engineering all about bridges and stuff?
Well, sure it is. Or at least that's one aspect, called civil engineering. But engineering in general is more about a disciplined approach to developing reliable, complex systems. And computer systems sure are complex. See, there didn't used to be any standardized approach to developing software. If you had talented programmers and they talked to each other, well, you were lucky. If not, the software didn't work, or it took 5 times longer to develop than expected, and your company rapidly went down the tubes. But over the last 10 or 15 years, people have found ways of applying good engineering techniques to software development. Proper specifications, techniques for incorporating existing modules into their systems, proper techniques for testing and evaluating the products, including how easy it is for humans to use them. Navman have been successful largely because they used sound engineering techniques all the way through the development process. I mean, impressive just doesn't begin to describe what they've accomplished. And computer science was involved at every step. That meant a lot of programming, but you've got to understand that programming isn't the whole of computer science. The programming is the tool that we use to turn the designs into reality, but the computer science is in devising a practical, reliable, well-engineered design for a whole computing system that will work and will solve a complicated problem. About the only part of the whole development that wasn't computer science was the choice of colour for the case. Although, in fact, they could have used the research that I'm doing into automatic techniques for choosing colour combinations. Did you know that Munsell's work on the formalised grammar...
Dad.
Oh, I'm sorry. I suppose I've used up this month's allowance of explaining complicated things to Hayley.
This year's?
Ah, OK. I'll let you go then, shall I?
Yes, please.
You could think about enrolling in computer science when you come to varsity.